Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as organic hydroxy compound. Let's start. What do you understand by organic hydroxy compound? What do you understand by organic hydroxy compounds? Organic hydroxy compounds are those compounds which contain a hydroxyl group in their molecule. So a compound containing hydroxyl group in their molecule is called as a hydroxy compound. The organic compounds which contain hydroxyl group in their molecule are known as organic hydroxy compounds. Right? So that is hydroxy compounds. Next, what do you understand by alcohols? What are alcohols? Hydroxy derivatives of aliphatic hydrocarbons are called as alcohols. Right? What are alcohols? They are hydroxy derivatives of aliphatic hydrocarbons obtained by replacing one hydrogen atom by hydroxyl group are known as alcohols. That means in aliphatic hydrocarbons CH3H, if I replace an hydrogen by hydroxyl group, if I remove the hydroxyl and instead of that if I put a hydroxyl group, then what I get is called as alcohol. So what are alcohol? They are hydroxy derivative of aliphatic hydrocarbons obtained by replacing one hydrogen atom by one hydroxyl group. Right? How do I classify alcohols? Alcohols are classified into four types. First, monohydric alcohols. What are monohydric alcohols? These are those alcohols that are obtained by replacing one hydrogen atom by one hydroxyl group. Obtained by replacing one hydrogen atom by one hydroxyl group. Right? They are generally represented as ROH. Fine. Okay. Next, the second type of alcohols that you have is dihydric alcohols. What are dihydric alcohols? Dihydric alcohols are those alcohols that are obtained by replacing two hydrogen atoms by two hydroxyl groups. Right? Obtained by replacing two hydrogen atoms by two hydroxyl groups. Right? And these are also called as diols. Right? Dihydric alcohols are also called as diols, or they are also called as glycols. That's how you name dihydric alcohols. Next, the third type of alcohols that you have is trihydric alcohols. Trihydric alcohols. These are those alcohols that are obtained by replacing 3 hydrogen atoms by 3 hydroxyl groups. Obtained by replacing 3 hydrogen atoms by 3 hydroxyl groups, right? And they are also called as triols or glycerols. Triols or glycerols, right? So they are obtained by replacing 3 hydrogen atoms by 3 hydroxyl groups. They are called as triols, or they are also called as glycerols. And the last one that you have is polyhydric alcohols. What are polyhydric alcohols? These are those alcohols that are obtained by replacing all the 4 hydrogen atoms by 4 hydroxyl groups, right? Obtained by replacing 4 hydrogen atoms by 4 hydroxyl groups. Fine, and they are also called as polyhydric. That's it. They are called as only polyhydric alcohols. Fine, do we get this in here? So that's how you classify alcohols. Next, how do I classify monohydric alcohols? Classify monohydric alcohols. How do I classify monohydric alcohols? Now, monohydric alcohols are further classified as primary, secondary and tertiary alcohols. They are classified as primary alcohols. What are primary alcohols? Primary alcohols are those monohydric alcohols that have hydroxyl group attached to the primary carbon atom. Primary alcohols are monohydric. They are monohydric alcohols having hydroxyl group attached to primary carbon atom. Fine. Okay, now that is what is primary alcohol. Secondary alcohols, next is secondary alcohols. What are secondary alcohols? Secondary alcohols are those monohydric alcohols in which the hydroxyl group is attached to the secondary carbon atom. Right? These are monohydric alcohols in having hydroxyl group attached to secondary carbon atom. Right? Third. The third is tertiary alcohols. What are tertiary alcohols? Finally, they are those monohydric alcohols having hydroxyl group attached to tertiary carbon atom. These are monohydric alcohols having hydroxy group attached to tertiary carbon atom. So that's how you classify monohydric alcohols. Next, let's move on to the nomenclature, guys. Nomenclature. Alcohol, common name, IUPAC name, right? CH3OH, one carbon atom, therefore me, right? One carbon atom, therefore me, so this will be methyl alcohol, right? IUPAC name, organic comes before inorganic, so this is going to be methanol. One carbon atom, therefore methane, alcohol, therefore OL, right? Then you have CH3CH2OH, two carbon atoms, therefore ethyl, OH, therefore alcohol. IUPAC name, two carbon atom, therefore ethane, alcohol, therefore OL, so ethanol, right? Next you have CH3CH2CH2OH, three carbon atoms, therefore propyl, OH, therefore alcohol, right? Three carbon atom, therefore propane, alcohol, therefore OL, propanol, right? Next, CH3OH, right? Three carbon atoms, therefore propyl, OH, therefore alcohol. OH is attached to the secondary carbon atom. This is my primary carbon atom, this is my secondary carbon atom. OH is attached to the secondary carbon atom, therefore sec propyl alcohol, right? And its IUPAC name, three carbon atom, therefore propane. OH is attached to the second carbon atom, therefore 2, and alcohol, therefore OL. Propane to all, right? Next, CH3, CH2, CH2, CH2OH, right? Four carbon atoms, therefore butyl. OH, therefore alcohol, right? Four carbon atom, therefore butane. OH, therefore OL. Alcohol is OL. Next, let's see. CH3, CH, CH2OH, CH3, right? How many carbon atoms? Four carbon atoms, therefore butyl. OH, therefore alcohol. Alcohol is not in the chain, but methyl group is in the chain. When methyl group is in the chain, you write it as iso. So this is going to be isobutyl alcohol, right? Do we get this? Had alcohol group been in the chain, then it would have been sec-butyl alcohol. Here methyl group is in the chain, therefore this is going to be isobutyl alcohol. Fine, do we get this thing clear? IUPAC name, consider the primary chain. What is the primary chain? The chain that contains maximum carbon atom is a primary chain, that is your straight chain. Straight chain has got three carbon atoms, therefore propane. Alcohol, therefore OL, right? Now, alcohol is attached to the first carbon atom, therefore 1 OL. Now, if this is my first carbon atom, this is my second carbon atom, the branch is attached to the second carbon atom, and what is there in the branch? Methyl. So, this is going to be 2-methyl propane 1-ol. Or some authors even write this as 2-methyl 1-propanol. Either way is right. Okay. Next, let's see this. CH, CH, CH2, CH3, OH. I'm putting the OH in the branch. How many carbon atoms? 4. Therefore butyl. OH, therefore alcohol. Alcohol is in the OH group is in the branch. Therefore sec-butyl alcohol.
Make that CH. CH3, the first one.
CH3, CH. OH, CH2 and CH3. So this is sec-butyl alcohol. Primary chain. Now the primary chain should contain my functional group, right? So in that case, this is my primary chain. Primary chain has 4 carbon atoms. This is butane. OH is attached to the second carbon atom, so butane 2-ol or 2-butanol, either way. Fine, do we get this thing here? Next, let's see this. CH3C, CH3, CH3OH. Right? Here, OH is connected to a carbon atom which is connected with another 3 carbon atom. That means this particular carbon atom is a tertiary carbon atom. Total number of carbon atoms 4, therefore butyl. OH, therefore alcohol. Attached to the tertiary carbon atom, therefore tertiary butyl alcohol. Right? Do we get this thing here? Primary chain, the chain that contains maximum carbon atom. The straight chain moving down contains maximum carbon atom. Right? 3 carbon atom, therefore propane. Right? OH is attached to the second carbon atom, therefore 2-ol. Methyl group is attached to the second carbon atom, therefore 2-methyl. So this is going to be 2-methyl propane 2-ol. Fine, do we get this thing clear? So do we understand the nomenclature of this? Next, let's see the methods of preparation. Methods of preparation. First is by hydrolysis of alkyl halide. First method is hydrolysis of alkyl halides. Right? When you, for example, I'll explain this to you with the help of a reaction. What happens when ethyl chloride is hydrolyzed with aqueous KOH? Ethyl chloride is hydrolyzed with aqueous KOH. Right? Ethyl, that means 2 carbon atom. Chloride, Cl, put your bonds. We know that valency of carbon is 4, out of which 1 bond is already here, so this will be H3. 2 bonds are there, therefore H2. This is your ethyl chloride. Ethyl chloride reacts with KOH aqueous in the presence of ethyl alcohol. No, you heat this, sorry. You heat this. When you heat this, you will have substitution reaction taking place. K will react with Cl to give you KCl, and this will give you CH3, CH2OH. This is ethyl chloride, and here 2 carbon atoms, therefore ethyl, OH, therefore alcohol. So when ethyl chloride is hydrolyzed with KOH, you get ethyl alcohol, right? Let's see another reaction of this kind. What happens when isopropyl chloride is hydrolyzed? Isopropyl chloride is hydrolyzed. Propyl, 3 carbon atoms. Iso, that means one of the carbon has to be in the branch. Chloride, that means Cl. So this is going to be CH3, 3 bond, therefore CH, CH3, Cl. Isopropyl chloride, right, is hydrolyzed. KOH aqueous. Heat, right? Substitution reaction. So you will get KCl plus CH3, CH, CH3OH, right? This is your isopropyl chloride, right? 3 carbon atoms, therefore propyl, and you have, this is going to be isopropyl alcohol. CH3 is in the branch. Isopropyl alcohol. Fine, do we get this? You could also do this reaction by using silver hydroxide. How would I get silver hydroxide? If silver oxide reacts with water, you get silver hydroxide. Now let's see this. What happens when ethyl iodide reacts with silver hydroxide? Or ethyl iodide reacts with say silver oxide and water. Right? Ethyl iodide, ethyl, 2 carbon atoms, iodide, I, CH3, CH2I reacts with silver oxide and water. Silver oxide, boil this solution. If I boil this solution, this will give me silver hydroxide. Right? In which case, I will get this as substitution reaction. I will get silver iodide, AgI plus CH3, CH2, OH. This is ethyl iodide and this is ethyl alcohol. Right? Let's do one more reaction of this kind. What happens with isopropyl chloride? Isopropyl chloride with silver oxide. Right? Propyl, 3 carbon atoms. Iso, 1 carbon atom has to be in the branch. CH3 chloride, Cl, reacts with silver hydroxide, which is obtained by boiling silver oxide. Right? Substitution reaction, you will get silver iodide plus CH3CH, CH3OH. This is isopropyl chloride and this is going to be isopropyl alcohol. Right? Okay, we will stop this here for the day. Thank you very much.